Displaying data as a graph is a great way of being able to see trends that happen across the data and looking for things that stick out or don't stick out. The type of chart or graph that we use will depend on the sort of data we have. For example, if we have categorical data, then all of these types of charts or graphs are good to use. Dot plots, line plots, pictograms, bar charts and pie charts are all good. If I've got numerical data that has discrete values, that it means fixed values without the fractions in between, then dot plots, line plots, histograms, frequency polygons and stem and leaf plots are good to use. And if we've got continuous data, then histograms, frequency polygons and box plots are good to use. This is an example of a dot plot. You can notice that along the x-axis we have the thing that we're interested in, which is the number of takeaway meals. And as always, up the vertical axis is the frequency, how often we counted that number. So it's pretty easy to see because of the dots that 2 takeaway meals per week, there were 1, 2, 3 people doing that in this Year 10 class. An important part of any graph is to keep the scale consistent. So you'll notice that each dot is the same distance away from the horizontal axis. Make sure that you spread them out evenly. The next graph I've got is a line plot, which is very similar to a dot plot. There's the values across the bottom, and vertically we're counting the frequency of each number. There are 3 7s that have been counted, 2 9s, etc. Looking closely at this one, whoever did it didn't quite do it very well, as these lines, these 2 X's here are not really lined up properly. So when you do it, make sure you line them up well. In a pictograph, we use a picture to represent a certain number. In this case, a picture is worth 4 pizzas. So Alan has had 4 pizzas plus another 2, which is 6 altogether. Again, be very careful to line them up underneath each other perfectly, otherwise the graph won't have as much value. It'll be harder to tell which one is the tallest and the shortest. Pie charts are good to find out what fraction each item that you're counting takes up, in this case breeds of dog. So I can easily see that this category here, which is border collies, takes up the most. But to make a pie chart takes a little bit extra work though, because you've actually got to convert all these numbers over here into degrees on the graph, or degrees on the circle. So we actually have to calculate each of those. Now you could turn it into a percentage first, or you could just use the numbers as raw data. If I was using the numbers as raw data, I need to split up the 360 degrees for each particular type of dog, breed of dog. There are 25 dogs altogether, and a Basset Hound is 3 of them. So that means 3 out of 25 is the fraction for Basset Hounds. Now we need to convert that into a fraction of degrees. So I just multiply by 360 and I'll find out how many degrees I need to use to draw the Basset Hound on the pie chart. And this is equal to 43 degrees. So when I draw the Basset Hound, I need to use an angle of 43 degrees. When we have group data, a histogram is a good graph to use. A histogram is basically a column graph, and you can see from this one here that I've got numbers between 45 and 49, and there was 2 of those counted. So down here I've written 45 with a little minus sign indicating that it goes up to 50. This column is 50 to 55, this column is 55 to 60, etc. And it's just a graph where the height is the frequency. A frequency polygon is a line graph, and you can see I've drawn the lines here on top of the histogram, and the frequency polygon follows the tops, indicating where it goes. So it's just a line graph. A stem and leaf plot is an interesting one because it's a graph and a chart at the same time. In this example, the stem, which is down the left-hand side, is 40, 50, 60, 70, 80, 90. The 4 here represents 44. The 5, 45, the 7, 47, and so on. Well, now one of the good things about this is it looks like a graph because you can see this is the tallest part of the graph, and this one's the shortest. It's on its side. Normally graphs go this way, but this one goes horizontally instead of vertically. However, you can easily tell which one is the biggest category or the biggest interval. Not only that, but the numbers are actually in the graph. So I know that this number here is actually 56. And so if I'm looking for the median, I can easily find it because they're already in order from smallest to biggest. A back-to-back stem and leaf plot is a great way of comparing two lots of results. In this example here, we've got girls and boys, and we could use this to look for differences in the graphs. You know, the shape of the graph, how many people are at each end, etc. Again, this number here, 51 for girls, this number here is 52 for boys. So the middle number is the stem, and these are the leaves. A box plot, or a box and whisker plot, is used to show the median and its associated quartiles. So let's have a look at this one here. In the middle is the median. Just above it is the upper quartile, and above that the upper extreme, or the maximum value that we've found. Down below is the lower quartile and the lower extreme. To make a box plot, you need the 5-figure summary. That is the minimum, lower quartile, median, upper quartile, and maximum. They're the 5 numbers that make up these points on the box plot. So, if you're going to plot or draw a box plot, you basically need to calculate or know these 5 numbers. Mark them off on your scale, there, and there. Draw in your box and your whiskers, and you have a box plot. So the good thing about a box plot is it shows how spread out the numbers are. In this distribution, they're fairly even. This quarter of numbers up here is a bit more compact or squashed together than this quarter down here. These are fairly consistent, but it is possible to get something like this. In this box and whiskers plot, a lot of the numbers are squashed into a very similar value, or they're very close in value, and half of them, that is, and the other half are fairly spread out. So this is a skewed distribution. You'll notice that we've ignored this outlier here because we don't think it's fitting in with the rest of the numbers. Something else you can also get from a box and whiskers plot is the number of data points that are below a certain value. So for example, this is the minimum value, we're ignoring this outlier. Below this number here, which looks to be about 32, we've got a quarter of the numbers. Below the median, which looks to be about 55, we've got half the numbers. Below this number here, the upper quartile, which looks to be about 76, we've got 3/4 of the numbers below that value. And all the values are below 90.